So now we're going to consider the y-coordinate of the center of mass. So when I was first reviewing this for this project that we're going to do, I thought that what would make sense is to now cut the shape the other way and create, cut parallel to the x-axis and do a dy integral. It turns out, though, that it's actually much easier to get the y-coordinate while still integrating with respect to x. So I'll show you what that looks like. So we're still dealing with this shape with 4 minus x squared ln of x plus 3. We're still looking at rectangles like this. We still have a density delta, and the mass of each rectangle is still delta g of x minus f of x delta x, because this expression here refers to the area of a sub I, the ith rectangle. All right, so the y coordinate we're going to call y bar, and just using the same formula for point masses to start with, it's the sum of y sub I m sub I over sum of m sub I. So this is why it occurred to me, we'll probably do dy on this. But it turns out that you can consider this like this. You can say, okay, well, all we need is this y-coordinate. The masses don't depend on y. So we'll just look at what the y-coordinate is of this center of mass. So that, remember, this is the center of mass right here of my ith rectangle. So if I go down to here where the x-axis is, it might not be exactly there. I think it is, actually. There's where the x-axis is. And then we'll say, all right, how high is the center of this strip? Well, the center is the midpoint of g of x and f of x. It's the center of that segment from g of x to f of x. So if I find the midpoint of the segment, the midpoint is going to be y2 plus y1 over 2. It's the mathematical average, or the arithmetic average, of the highest and lowest point. So in fact, that y sub I, that's going to be this y sub I here, is equal to g of x sub I plus f of x sub I over 2. So that's just the average of the two y coordinates. That's going to be the center. All right, so now we can go into this expression and say, I'm going to develop it into an integral by taking the limit as delta x approaches 0 and n approaches infinity. And what I'm going to do for this, so I'm going to have an integral. Let's put that first, integral from a to b. But what I'm going to put for the y is this expression. So I'm going to have g of x plus f of x over 2. That's just the y part. And then the m part is this expression. So times delta g of x minus f of x, and the delta x becomes dx. So that looks complicated, but it actually simplifies quite a lot. So the delta x from here has become the dx from here. This expression right here is still the mass expression, so that's the mass. And this expression right here, which is from here, that's the y sub I. All right, so the m sub I showed up here. All right, so then, now our denominator does not change. It's the same as it was before. It's the mass. Really, this, when we change that mass into the integral from a to b of delta times g of x minus f of x dx, what you really have down here is actually the total mass of the shape. So that's another interpretation layer that's in there. All right, so what can we do? We can cancel out the deltas. We can bring the 2 out, the 1/2 out to the front. We could even drop that 2 down to the denominator if we wanted. I think I did that in the project sheet. I think I will not do it here. But here's the other critical thing. G of x plus f of x times g of x minus f of x. So you guys all know that a plus b times a minus b is equal to a squared minus b squared. So that's what we're going to do with the numerator. So then that ends up being equal to, we're going to pull the 1/2 out. I have the integral from a to b of this expression is going to give me g of x squared. So I'll write g squared of x. I think we're familiar with that. Minus f of x squared. So I'm going to write f squared of x. So of course these refer to g of x squared and f of x squared. not the second derivative of g, and so forth. So we understand that from the context. Okay, so then, and also what I've done is we can cancel the deltas, so I didn't put the delta in. So our denominator ends up being integral a to b of g of x minus f of x dx. And so there you have it, an expression in integrals with respect to x that gives the y coordinate of the center of mass. So for our particular expression, we're going to say that the y bar is equal to 1/2 times the integral from -2. This intersection point is the same thing it was before, 1.575. And then I'm going to have 4 minus x squared squared minus ln of x plus 3 squared, that's a parenthesis right there, dx. And that is all going to be over the integral from -2 to 1.575 of 4 minus x squared minus ln of x plus 3 dx. So that's my expression. It looks complicated, but I have a lot of these things in my calculator already. So I can just go in here and do, all right, so now we're going to do, let's go ahead and, now we'll do them separately. So I'm going to have 1/2, so let's call that 0.5, just doing the top here. And then we're going to do integral, so it's math 9. And I'm doing from -2. Now I still have the x from my intersection that I calculated before. So that x that I'm putting up there is the 1.575 from my graphing window. And then I can just put in variables, y vars on my 4 minus x squared is y1, so y1. And then I have to make sure I square that, and then minus vars, y vars, y2 squared. All right, and that's this minus this. This is y1 squared minus y2 squared and dx. So that's just my numerator. I'll do my numerator separately. We could be crazy and put the whole thing into one big expression, but you know, why take a risk? Now, this is a much larger number than I have in my original work. Yeah, maybe not. Maybe we'll see how it comes out. We'll see if it comes out to what I expect it to come out. Otherwise, I'll have to redo this whole video, which will be fun. Okay, so then I'm going to do just copy this integral. I need to take out the squareds. So we're going to delete that squared. I'm going to take out this squared, delete, because I'm doing the denominator now. Take out the 0.5, so delete, delete. Oh, I deleted the integral. That's unfortunate. Okay, so let's just put the whole thing in. Math 9, integral 0, no, it's -2 to x of variables y vars function y1 minus variables y vars function y2. We want dx. Enter. Okay, now I'm going to do, that's my numerator, so this number divided by, this is my denominator, so that number, and it equals 2.156, which is in fact what I calculated before, so I'm happy with that, equals 2.156. All right, so now I know what that y coordinate of the center of mass is. So if I come back to my graph of this shape, and I put in the equation y equals this number, which is 2.156. Now, this point right here, that is the center of mass of this shape. All right. Now, the cool thing is that we can actually cut out this shape and demonstrate that. So that's what's coming next.